As you're reviewing for your test, keep in mind there will probably be one problem like number 1 and 2. Number 3, on the quiz, a lot of people missed this, I think because they didn't follow directions. So the first step is to determine the number of solutions. So in A, these two lines don't cross, so there are 0 solutions. In B, the lines cross in one place, so there is 1 solution. And in C, the two lines are right on top of each other. They are the same line, so there are infinitely many solutions. The second part of this says, state whether each system is consistent or inconsistent. Consistent means solutions. So one solution, that one would be consistent. Many solutions, that one would be consistent. No solutions in A, that would be inconsistent. So on that particular problem, I think I might make it like a circle, so you have to circle within both columns so you don't forget to answer all of that. There will be a word problem very similar to number 4 on the test, but I think on the test I'm going to make it so that you have to write the equations and then that's it. You don't have to actually solve it, you just have to write the equations. So let's go through this fairly quickly. Ticket sales for an annual variety show were $2,255 for the first night and $1,265 for the second night. On the first night, 140 student tickets were sold, 180 general admission tickets were sold. On the second night, 80 student tickets were sold, 100 general admission tickets were sold. So do you see how there's information about the first night and information about the second night? That's where we're going to get our two equations. So on the first night, we had 140 student tickets sold. You can use X or S for student tickets. You also had 180 general admission tickets sold. Those two numbers, 140 times the amount that each of those tickets is, 180 times the amount that each of those tickets, that would equal our total amount of $2,255. Once I write that equation, do you think you could write the other equation? On the second night, 80 student tickets were sold, 100 general admission tickets were sold. How much did we collect on the second night? $1,265. So on the test, I would ask you to write those two equations. It will be a very similar scenario to number 4. So if you feel like you can read number 4 and get those equations written down, you'll probably be able to figure out the problems, the equations on the test. I'm almost guaranteeing that number 5 will be on the test, so let's talk about it. For what value of A would the following system of equations have an infinite number of solutions? The first thing I'm going to do is just pretend that that A is not there. I'm going to act like I want to solve this system. So I see 2x and 6x. I would probably multiply the top by -3. That would give me -6x plus 9y equals -24. And the original second equation, +6x minus 9y equals 4a. I would add these together. What is -6x plus 6x? 0. 9y plus a -9y is 0. And this would be -24 plus 4a. What do we want this to be in order for it to be infinite number of solutions? We really want this number to be a 0. In order for it to be an infinite number of solutions, you must have a true statement. So 0 equals 0. So we need -24 plus 4a to equal 0. So a has to be 6 because 6 times 4 is 24, and -24 and +24 would give us 0. So 6 would have to be the correct answer. So on that type of problem, ignore the A and just pretend that you're solving the system and think about, what number do I need right here? I need a 0. What does A have to be to make that actually happen? Okay, number 6, I crossed it out because, quite frankly, this is a really dumb problem. And they tried way too hard to make this way more complicated than it needed to be. $36. One person worked 3 days, the other person worked 1 day. So take 36 divided by 4 and get 9. So the person that worked 1 day gets $9. The person who worked 3 days gets $27. Done. Why in the world would you make it this complicated with 2 equations? That's just, no. So there will not be a question like number 6 on the test because that was a really dumb problem. Okay, on the quiz, a lot of people missed answers for number 7 and number 8. Number 7 should be the easiest problem on the test. Basically, you're trying to fill in these blanks. X goes in the first blank, Y goes in the second blank, Z goes in the last blank. So you already know that Z is -2. This is called back substitution because you basically start at the bottom line, plug that into the line before it, figure out Y, and then plug both of those into the line before it to figure out X. So you would take this -2 and plug it in right there into Z. So you'd have 2y minus a -2 equals -12. Figure out what Y is. Once you know what Y is, you're going to plug Y in right here, and you're going to, again, plug the -2 in there, and then figure out what X is. So it's just substitute, solve, substitute, solve. Number 7 should be ridiculously easy. Number 8. In number 8, before you do anything, you want to look at the variables that you have and keep in mind that you need to eliminate the same variable twice. So if I look at my Y's, yeah, we could eliminate the Y's twice, but with 6 and 5, you'd have to multiply both equations by something. The first one and the third one would eliminate pretty easily, but then for the second one, you'd have to multiply both equations, and that just doesn't sound like very much fun. You could probably eliminate your Z's if you wanted to. First, you would try to get -4Z and +4Z. Then you would try to get 2Z and -2Z. So you definitely could do that with your Z's. I think the easiest way to do this would be the X's. Because when I look at those X's, what do you see about the first 2 equations? They will already eliminate. So if we've got X plus 5Y minus 4Z equals -4, -X plus 6Y plus 2Z equals -12. Let's eliminate those 2. So the first time I eliminated, I used the first and the second equation. I left them exactly as they were, and the X eliminated. So I have Y and Z. Now I want to use the negative, so the middle one, and the last one. In order to make these X's eliminate, what am I going to have to multiply the middle one by? 6. So if we take the middle one times 6, we would have -6x plus 36y plus 12z equals -72. The original second equation, we'd keep the same. And this might involve using a calculator. Okay. We have eliminated the x's twice. Now we have two equations that both have y and z. If we tried to eliminate the y's, we're working with 11 and 31. Does that sound like any fun whatsoever? No. -2 and +11, we can work with that. I'm going to multiply the first equation by 11. That would give us -22z in the middle. If I want the other equation to be +22z, I need to multiply that one by 2. So 11 times 11y is 121y. 11 times 2z is -22z. And 11 times -16, I cannot do in my head, so I punch it into my calculator. -176. Now I'm going to multiply 2 times that second equation. 2 times 31y is 62y. +22z. And -95 times 2 is -190. Add those together. We get -183y equals -366. Divide both sides by 183. Sorry, I'm totally talking crazy right now. And we get y equals -2. So ultimately, we are trying to figure out what goes in each of these blanks. We now know that y is -2. Now we're going to take this y equals -2 and plug it into one of the original equations. And I'll be honest, this 31y, that looks gross to me. So I'm going to plug it into this one. 11 times -2 is -22 minus 2z equals -16. Yes, I'm totally doing the work into number 9. It's totally fine. So -2z equals -16 plus 22, 6, which means z is -3. Once you know that z is -3, now you need to go back to the original problem. And it's probably easiest to find an equation that has plain x in it. So I'm going to choose the top equation. So x, which we don't know, plus 5 times -2, so that would be a -10, minus 4 times -3, that would be a plus 12, equals -4. So all I did was plug the -2 in here and the -3 in there. So that's x plus 2 equals -4. So x equals -6. There will definitely be at least one problem like number 9. It might be a multiple part problem, probably not, where you have to determine the order. Remember, the order is the dimensions, and it's always number of rows, so this is 4, by the number of columns, 2. There will be a problem like number 10 where you have to scalar multiply, so just distribute into the matrix, and a problem like number 10b where you have to do simple addition or subtraction of matrices. For the graphs, I would guess that it's going to be more similar to number 13. So make sure you feel really good about how to do number 13. Remember, when you divide by a negative, what happens with your sign? It flips. That would make this positive 1/3 x minus 6. Only when you divide by a negative. When you multiply or divide by a negative, that sign flips. So keep that in mind on number 13. Make sure you practice your shading on those problems as well.